think there is some relationship between ancient architectures and sacred geometry.
Yes, the relationship is kind of what we've been talking about in a sense all along, in that sacred geometry was provided the basis for the template for all of these ancient structures. So there was many buildings, and maybe in a follow-up, podcast that we do, we could explore the architectural aspect of it in much greater depth, because there is a lot more that we could look at. The Great Pyramid is kind of like in a way, is a repository of sacred geometry knowledge. There's a lot of different ideas and things associated with the Pyramid of Egypt, the Great Pyramid. I think some of them are pretty far out there. There's one relationship, though, that really, in a way, makes a lot of sense to me and can actually be demonstrated with a high degree of rigor. And this is the Great Pyramid as a geodetic model. By that, I mean a particular three-dimensional geometric form that encapsulates the proportions of the Earth on a scale, right? A scale model of the Earth. And we can talk about that if you'd like to see how that works. If we look at this slide here, we see basic the geodetic configuration of the Earth. On the left, we have the parallels, and they're called parallels because they run parallel to the equator. And you can see, obviously, when you look at that, the parallels, the largest parallel that's going to be measured is going to be the equatorial circle of the Earth. And then as you move towards either one of the poles, those parallels, which are lines of latitude, they shrink and essentially come to a theoretical zero at the two poles. And then you take the meridian lines, which are lines of longitude, that even though they go north-south, what they're doing is they're measuring east to west distances. And so you have meridian lines. Now, the thing about the Earth is it's not a perfect sphere. As it spins on its axis, it's a pliable structure, if you will. Because it's spinning, the mass is thrown towards the equator. So the equator bulges out relative to the pole. So you have two measures of the Earth, the equatorial diameter and the polar diameter. The equatorial diameter is 26 miles greater than the polar diameter. Or another way of saying it is that the equatorial radius is 13 miles greater than the polar radius, right? And that is because the Earth is the geometric term would be an oblate spheroid, right? Okay, so if we look at the length of the degree of the meridian, we won't get into this in much detail, but this is simply, they're called ellipsoids, and these are what are used for navigation, for satellites, for all kinds of anything that has to do with movement around the surface of the planet. And if you look here, length of 1 degree on the meridian, you'll see that at the equator, it says in miles, 68.703 miles. If you come down towards the pole, what you'll see is it's 69.407. So it's almost a mile greater for 1 degree, because what's happening is as you're moving towards the pole from the equator, the Earth is flattening out. So you have to go farther. See, all of this is determined relative to the position of the stars in the sky. So if you're standing at the North Pole, Polaris, the North Star, is going to be directly overhead. If you were to travel from the North Pole down to the equator, what's going to happen, the further south you go, the lower the pole star is going to be towards the horizon. Until, picture, if you're at the North Pole, it's directly overhead. As you get down to the equator, it's going to actually just be on the horizon, see? And what will happen is, as you move from equator towards horizon, because of the oblateness of the Earth, the arc is steeper at lower latitudes, and then it flattens out as you get into the upper latitudes. So you have to travel farther to get that star to move 1 degree in the sky. And so that's what's happening here, see? So that's one thing, how you can show that depending on where you are on the surface of the Earth, the way you measure distance on the Earth, which is lines of longitude east and west and lines of latitude north and south, is going to vary. So a line of latitude at the equator is going to be smaller than that line of latitude at halfway up at 45 degrees. Okay, and then we look at the parallel, which is this. And there you'll see that 1 degree at 0, which is the equator, is 69.172. Then when you come down here to 89 degrees, which is just 1 degree off of the North Pole, it's only 1.211 miles. So it's almost shrunk to nothing, see? So there's your lines, your parallel, getting like this. So now, if you were to say, we are going to use a unit of measure based on the Earth, right? Now, when we talk about the metric system, meters are based upon the size of the Earth. The length of the meridian, 1/100,000th of the length of the meridian from equator up to pole. Well, and it's a natural thing to do, is to try to tie your units of measurement into the dimensions of the Earth. And this is what the ancients did. But they went even a step further by adjusting their units of measurement according to where on the Earth the structure was being built. And this is kind of complicated. Without a lot of diagrams and a little bit of math, it would be difficult to demonstrate this. And maybe we could put this together for a future podcast. But the point is that this is going to be variable depending on where you are on the Earth. These units are not uniform over the whole Earth. They vary, okay? We will go on. Okay, so let's keep going. So here's some geodetic data, official ellipsoids in use throughout the world. And you can see where in use these different, the oldest one, the name of it's the Everest. It goes back to 1830. And the newest one is the Global Reconnaissance System 80, which goes back to 1980. It was adopted in 1980. NASA, U.S. Department of Defense, still uses the World Grid System 1972, because it's so accurate that, you know, an inch or two in variability is not going to make much difference in the real world. Because the thing is every time you take these measurements, like here's, see, this is equatorial radius, here's polar radius. And every time you take these, they're going to vary a little bit because the Earth is somewhat of a plastic body. It will bulge and it will move, you know, depending on, for example, is the moon during one of its closest passages to the Earth or farther away, right? That can affect the way the Earth, the mass of the Earth is distributed. You know, of course, everybody knows that because of the moon rotating around the Earth, it creates ocean tides, right? Well, there's also tides in the solid material of the lithosphere as well. So the point is at some point you can go, you reach the limits of precision because the thing you're measuring is not perfectly static. It's going through some changes that might amount to a few feet over the course of the whole planet, see? So what's the point of trying to get more and more accurate beyond a few inches? You see, it doesn't make any sense. But the point is you've got all of these, and you can see equatorial radius, polar radius, this is all in meters, right? So the reason we're going through this is so that you can see something very interesting. Here's the length of 1 degree of the parallel at the equator from the Clark spheroid of 1866 to the International spheroid of 1924. You'll notice the difference here. The difference is a little bit, close to 10 feet. And that's probably going to be as close as you can get. Maybe within a meter being roughly 3 feet or a little more. Okay. What's interesting about this is when you measure these in feet, you basically get 1,000 times the number of days in a year. You see, that's what these numbers are right here. 1,000 times the number of days in a year. 300, almost a little bit less than 365 and a quarter days, right? Rather curious coincidence. Okay, then you have one length of 1 minute of parallel. There I'm using the same two ellipsoids again. And you'll see how close they are. They're both 6,087. This is 0.258 and that's 0.09. So, you know, even by 1924, they hadn't improved that much. And yeah, okay, and so here's one tropical year contains that many days, right? 1,000 tropical years contains this many days. So you can see how close this is using that particular ellipsoid. Right, okay, so here it is. It's only 6.709 feet short. In other words, if you added another 6.7 feet to it, to the circumference, the equatorial circumference of the Earth, it would have just as many feet in it as there are days in 1 year. That's interesting, isn't it?
Yeah.
It's, yes. 1,000 years. So it's pretty darn close. All right, so length of the degree of parallel at various latitudes, and you can see how 0 at the equator, it's large, and then it gets smaller and smaller as you're going towards the pole. Here it is in feet. So, all right. All right, so here, let's imagine this line, this baseline, is the equator. 1 square degree of latitude and longitude at the equator. So the longitude east to west, 69.17, etc. miles. Latitude north to south, 68.7. Makes sense because the Earth is bigger this way than it is this way. So if you take 1/360th of it this way, it'll be a little bit bigger than 1/360th of it going this way. So there's you see, so this isn't a perfect square, is it? But it's close because what's happening is the vertical lines as you're leaving the equator are slowly converging, right? Because then when you get to the North Pole, the meridians converge right on the pole. Got a little square down here in the corner, right? So you've got 1 square degree. Degrees are divided into minutes of latitude and longitude. 1/60th of a degree is a minute. So this is 1 minute. 60 of those little squares, this way or this way. So now what we're going to do is we're going to go from a degree to a minute. All right? You'll see where this is going soon. And this is what we end up with. Here's 1 square minute of latitude and longitude at the equator. Again, this way is a little bit bigger, east-west, than north-south. Right? 6,087.094125 feet. Now, we're going to divide that into 1/4. So there's 1 minute divided this way and this way. So now you have 1/4 square minute of latitude and longitude, right? It's 1/4 of the square and it's half of the horizontal and vertical. And there's the numbers. So look at those numbers, 3,043.54 and 3,022, right? Those numbers then represent the difference between this and this, which is totally dependent on the fact of the Earth's oblate shape, its departure from a spherical shape, okay? So there we go. We're going to further reduce it. We're going to come down. We're going to cut that in half. And then we're going to cut this in half. And then we end up with these two numbers right here, right? 760.886 and 755.735. That's the little square I've got blocked off there. Now you can see this is totally derived from these geodetic delineation of the Earth. So now we're going to look at the Great Pyramid. William R. Fix, back in 1978, who wrote a wonderful book called Pyramid Odyssey, which I don't know if that's still in print, but he said, the history of man may be far longer and stranger than we think. The Great Pyramid may indeed not fit in with what we believe about the past and the nature of the world. Thousands of years ago, someone measured the Earth with remarkable accuracy and recorded this information in the dimensions of the largest and possibly oldest stone building on the planet. And if we take a profile, this, as I've said, I based this upon surveys of 4 different surveyors. William Flinders Petrie, Cole's Survey of Egypt, and A. Pocan, who was a surveyor who measured it, I think, in the 1960s. All three surveys are within a few inches of each other. So with a slight amount of adjustment, the numbers that we are using here are within the allowable or acceptable margin of error, right? So there's the profile. And the pyramid has a unique angle. Now, there's the height of the pyramid, 481 feet, and that's based upon the angle of the existing casing stones, because the top of the pyramid is missing, right? But if you look at the casing stones, it's 51 degrees, 51 minutes from the horizontal. And if you project those casing stones until they meet, those angles until they meet, you would get a profile of 481 feet and a base of 755.85 feet, right? There's your angle, 51 degrees, 51 minutes. If you put the ratio of 755.85 over 481, it's almost 11 over 7. 11 units over 7 units. And that will give you very close to that angle. Now, under the pyramid, there's a stone base that's 1 royal cubit in thickness, right? If you include that, as it's called the SOCLE, which is 1 royal cubit, which is about 20.6 inches roughly. Then the height of the pyramid becomes 482.7575, right? The base of the pyramid now becomes 760.9. So you actually have two ways. You measure the pyramid right here at the base of this casing stone, or you include the SOCLE, this 1 royal cubit thick base. So there's the numbers, total height. There's a picture of the casing stones, and here you see the SOCLE, 1 royal cubit in thickness, right? And then here are, based upon these surveys, here are the lengths of the 4 sides, and here's the total. Notice that number, right? So here's the length of the base on the SOCLE, and then the corner sockets, which defined the outer limits of the SOCLE. I think I have a slide here that shows, yes, here's where a corner socket was held. So you can measure to where the casing stone hits the base, or the corner socket stones that marked the corners of that base, which are now missing. But that's how we know. And there you can see the figure. Here's the socket that the stone went in, and here it shows the SOCLEs right here, and then here's the casing stone coming down. So the two ways of measuring it would be here and here. So that way you get 2 ways of measuring this, and you get 2 ways of measuring this, each slightly different, right? And so when you measure the distance between the corner sockets, you get these numbers, or the total measure around this number right here. Okay, there again you can see the casing stones, you can see the SOCLE right there. So there's the length of the base on the SOCLE. There's the total perimeter of the casing stones, total perimeter of the SOCLE, including the corner sockets. So in 2 seconds of time, there are 86,400 seconds in a full day, a tropical day, right? So that means that when you go through one circuit of the clock, like say from midnight until high noon, or from high noon back to midnight, there's half, 86,400, half of that is 43,200, right? So given 2 seconds of time, if you're standing on the equator, right, in one 43,200 part of the diurnal rotation, you count 2 seconds, right? A point on the equator will travel a distance precisely equal to the perimeter of the Great Pyramid's base as measured with the SOCLE. In 1/2 second of time, a point on the equator will rotate a distance equal to 1 second of the base of the Great Pyramid measured on the SOCLE. 1/2 second of time is 1 divided by 172,800 part of the diurnal rotation. Do you see that? Here is, in the dimensions of the pyramid, they're linking the measure of space with the measure of time. Let's go back and look at these numbers again. So 3,043.433 feet, that's measured with the corner socket, so that's the slightly bigger one. Okay, if you can just remember 3,043, we go, not including the SOCLE, we get slightly smaller, 3,023 feet, right? So now let's go back to this diagram here. And here it is, 760 feet, right there. See, so this one portion, you know how we drive this, that right there is the square of the pyramid. The pyramid would sit precisely on that. Is that making sense? Yeah, it's hard to see it at first, but you got to kind of follow it through. And here's the number, 760.88, that's the larger measurement, including the corner sockets. 755, that's the smaller one. So it's like right there, either this is a really wild coincidence, or they have constructed, somebody designed this thing so that the two measurements that define the difference between east, west, and north, south is enshrined in the two different ways you can measure the Great Pyramid. Now we'll come back to this, and we see that the height of the Great Pyramid measured with the SOCLE is 143,200th part of the Earth's polar radius. Because if we take the height of the pyramid, and I didn't bring my calculator, take it with the SOCLE, 482, whatever that was, and you multiply it by that the same scaling factor, that 43,200, what we now get is within a few feet of the polar radius of the Earth. So the Great Pyramid, the height of it, multiplied by 43,200 gives you the polar radius of the Earth. So they've included dimensional data for the surface of the Earth at the equator, where that difference is prominent, and they've included the polar axis of the Earth. So what that means is if you took the Great Pyramid and you enlarge it by 43,200, the square perimeter of its base would have, the square base would have the same perimeter as the equator, and its height would be the same as the polar radius of the Earth. So it would fit right inside the globe of the Earth. And not just an arbitrary number. See, 43,200 is one of these numbers that we've inherited that was always given significant meaning by multiple ancient cultures in their measurement of both time and space. Some of the Sumerian king lists, the Sumerian kings reigned for 43,200 years. In the Vedic Yugas, the Kali Yugas, 432,000 years. We see that in the measurement of the diurnal rotation of the Earth, 43,000, like for example, at the moment of equinox, right? At that moment, at that precise, let's say 1 second of time, where day and night are of exactly equal length, there are then 43,200 seconds of light and 43,200 seconds of dark. So what the point here is that it kind of integrates dimensions of space and dimensions of time. And there's more to it than this, but I thought I had a slide in here showing this, the Great Pyramid nested inside the globe of the Earth, but I guess it's not here. So we can look at it another time. And here, of course, if the vesica is really a universal symbol for creation, we see that notice we have a vesica nested within a larger vesica. As soon as we do that, look what we can do. set up a perpendicular, and it'll give us 2 points of contact here and there on the arc of the outer vesica. Then that connected back to the upper point of the inner vesica. There's our profile of the Great Pyramid. So it links back to this geometry as well. And one final thing, there's the profile of the Great Pyramid. And we see that if we place the base of the Great Pyramid at the equator and enlarge it, we get the Earth-Moon ratio. Let's see, so there's the moon, and here comes the Earth. And if we take the diameter of the Earth and the height of the Earth plus the moon, we discover that it's in that ratio of 11:7. So it's built in almost perfectly in the Earth-Moon relationship. Let's see. So I think that's, well, then the final interesting thing is how the Earth-Moon gives us the famous builder's version of the Pythagorean, of the 47th proposition of Euclid, also known as the Pythagorean theorem, with a 3, 4, 5, which was always a prominent symbol in early Masonic, and still is in Masonry. And we find that 3, 4, 5 triangle fits right into the Earth and Moon relationship there.
Do you think there was a bigger purpose to pyramids than just for storing mummies in there?
Well, I think clearly what we have here is evidence that somebody was able to measure the size and shape of the Earth, way back when nobody was supposed to be able to do that. So if you were, in an advanced scientific civilization that was able to measure the size and the shape of the Earth with a high degree of precision, let's say what we've been able to do in the last century or so, century and a half, and you wanted to preserve that information as a statement that, hey, somebody was here that understood geodesy to a high degree of sophistication, you build this giant model and you encode in it all kinds of interesting geometry and astronomy and geodesy, and there it is. Now, if we're thinking about like mystical property, okay, so I was basically saying that, and there may be unique energy properties to that particular geometry. I don't think there's been any definitive research on that settles yes there was or no there wasn't. Certainly I think the one thing that we can demonstrate with a fair degree of rigor is what I just showed you, and I kind of hurried through it, but the idea that the structure is there as a demonstration of someone's ability to do something that we've only been able to duplicate since the scientific revolution. Certainly within the last, you saw the earliest geodetic survey there was what, 1822 maybe, and subsequent surveys from then haven't really made it a hugely more accurate, even the ones that NASA and the Department of Defense are now using.
From your view, how long do you think it took to build pyramids?
God, I don't know. I've heard, some of the various accounts was that I've heard, 20 years based upon some writings. I don't really know. Certainly given the technology we assume they had in the Old Kingdom times, it would take a very long time. It's a lot of work there. And, engineers and scientists and builders and architects have all come up with various schemes for how the pyramid could be built. But even the most sophisticated of those schemes still imply a huge effort. And to be able to quarry the stones, particularly form the white limestone casing stones, and cut those stones and fit them with such precision, and to be able to move those stones into place, I mean, it's a conundrum how it was built. I'm not sure that anybody has the, excuse me, the final answer on it. I don't claim to know. But yeah, it's still a mystery, I think, how the pyramids were built. And see, it's so out of context because the assumption is that you basically had subsistence farming in the Nile Valley for thousands of years. And then within, what, 2 generations, these farmers basically are building a structure like the Great Pyramid. It just doesn't make sense, you know? And even you can talk about pharaohs and their egos all you want, but I mean, that's easy to say. But to build a structure like the Great Pyramid with what, 2.3 million stones in it, almost perfectly oriented to the cardinal directions over a 13-acre leveled site, and put these stones together with the precision, and and just maybe what, by accident end up getting this unique geometry built in there, and this geodesy, etc. No, it just, you know, I think that it almost gets down to where you're oriented psychologically and emotionally. Some people just can't deal with the fact that history might be other than what they've been spoon-fed, that it's this nice curve that does this, and that there's no mystery back here. Well, it was just, you know, basically roving migrant hunter-gatherers and then later subsistence farmers. But then all of a sudden, within 2 centuries, you've got a huge wave of building in Egypt. You know, you've got it in Asia. You've got the first wave of great monumental earthworks architecture in North America being built precisely at the same time, right? In Sumeria, you know, in along the Tigris-Euphrates Valley, in you know, the great ziggurats and the 7 cities of Mesopotamia, and Uruk, and these, well, they were being built at the same time. So it's almost like, again, it's almost like the orders went out, you know, the bell went off, and then everybody in these various cultures got up, and within a matter of a decade or 2, they're building these incredible structures. And then it seems like as fast as it started, boom, it was over with. So that to me is an interesting mystery of history that has not been adequately resolved. But clearly there's more going on in history than the standard models will allow for, you know. And when you look, to me, you look at the Great Pyramid, you can either do one of things. You can just shut your eyes and you can just dismiss it and say, oh, that you're just playing with numbers and stuff. Sure, but it's there. You know, it is a fact that if you scale the pyramid up by 43,200, you're going to get, in a sense, a scale model of the northern hemisphere of the Earth. I'm sorry, it's there. You either ignore it or you explain it away by saying it's just a coincidence, but you don't accept the fact that whoever designed, the architects that designed the Great Pyramid, may have known the size and shape of the Earth, because that's the implication. Now, if that was the only thing, if that was all by itself, the only thing that stuck out as anomalous, well, we could maybe ignore it, but it isn't. It's part of a whole body of things that don't make sense within the framework of the conventional models. And that's what Graham Hancock has been getting at for 20 some years, is saying, if we look at the past, there are just too many things that don't fit that standard narrative of, you know, hunter-gatherers, subsistence farmers, and then this slow arc up to modern civilization. What appears to be the more accurate graph of civilization, just like life on Earth, is sawtooth. It rises and then it collapses, rises again and collapses, rises again and collapses. And see, I think maybe there's a lot of folks that might struggle with the idea that we might just be one in a long succession of civilizations that have existed on this planet. And it's easy for them to dismiss the possibility because they don't understand the degree to which this planet has undergone complete renovation repeatedly. And if they did, they would understand how whatever may have existed in terms of the artifacts of civilization 20 or 30 or 50,000 years ago or longer, why we would find no trace of them. Because they do not understand how sweeping some of these great upheavals and catastrophes have been. once you really begin to understand that, and there's very few people on Earth today who've gotten this. It's taken me 40 years of study into the literature, talking to scientists that are geologists that are doing the work, going with Bradley, my colleague, out into the field, covering 50,000, 60,000 miles in the field before you can begin to put the pieces together and understand, yes, it's obvious. This planet has been remodeled to such an extent that whatever was here before, it's gone. See, that's the problem we're confronted with. And so it becomes easy for people to just, turn their back on this anomalous evidence that's out there and just assume there's some authority out there that has it figured out. I see this all the time online when people are challenging me, well, what would the real geologist, what would the real archaeologist, what would the real, whatever say? But the point is that, knowledge is so fragmented that, somebody might understand, there may be an archaeologist who has spent 20 years on one dig, and he can tell you in great detail every single thing about that dig and the lifeways of those people that live there. That doesn't necessarily mean he sees the big picture. It doesn't necessarily mean that he sees that this particular social group disappeared at the same time as another social group 2,000 or 3,000 miles away disappeared, right? We can see in North America, the Clovis culture. There are at least 50 known Clovis sites in North America that existed right at the end of the last ice age. They all disappeared at the same time. But if you were just looking at the original Clovis site out in New Mexico, for example, you wouldn't necessarily know that it disappeared at the same time as a Clovis site over on the Savannah River in Georgia, see? But now that we're in a position where we are getting the dating, we're able to look and see, yeah, they all disappeared at the same time. Coincidence, or is there some agency involved? See, and that's the point we are now coming. We're status quo science, hard science, is beginning to recognize what a lot of the fringe researchers have been saying for 20 and 30 and 40, even 50 years. Yeah, there have been catastrophes in Earth history, and that we have to be open to the idea that there have been civilizations and cultures that have come before us that did achieve a high level of sophistication and knowledge, and they've disappeared and left very little trace of their existence. At this point, to refuse to look at that is nothing but it's closed-mindedness. That's all that is. So I think we're at the kind of a front end of a major paradigm shift in the next decade or two, where we begin to understand that we go back 4,000 to 5,000 years of recorded history, but modern humans have been on the earth at least 40 times that long. Yet in all of that span of time, from 180 to 200,000 years ago, down to the beginnings of recorded history, nobody figured out how to accumulate knowledge and pass it on. Nobody was able to come up with, well, yes, each generation learns something and teaches the next generation, and eventually, there are a lot of mysteries and questions that need to be addressed about this vast time that humans have been on Earth prior to our written record of that. Because the written record is this, but the whole time that human beings have been on the planet is 40 times that long, see? So I think that we're on the verge of penetrating this veil that separates, say, the modern incarnation of the human species from the primordial incarnation. And the veil that separates these two is this events of the Younger Dryas, these events that occurred at the end of the last ice age during the transition through the age of Leo. And this is why when you look at the Sphinx, which is symbolic, the Sphinx in Egypt, what is it? Lion and man. In the zodiacal wheel, the lion and the man is Leo Aquarius, right? And that's that axis. 13,000 years ago, the spring equinox was pointing to Leo, and the fall equinox was pointing to Aquarius. Now it's going to be just the opposite 13,000 years later. So that number, which was half the cycle, that has come up over and over and over again in occult and esoteric literature, in the metaphysics and so on. And now we've got scientists using radiocarbon dating who are dating these events when the Clovis culture disappeared, when the great megafauna disappeared, when there were these amazing upheavals, and they're all coming in at 12,900 years. And so they are coming up with a date completely independent of what the archaic tradition has been telling us for decades. See? So there we have a convert. And I don't know of having now, gotten to know a number of the scientists that are involved in doing the Younger Dryas boundary research and reading most of their papers. I don't know that any of them are aware of the fact that the number 12,960 was prominent in these ancient archaic traditions of geometry.
That's amazing to know.
Yeah, it is, isn't it? And and it's the kind of stuff that if you're at all skeptical, you can verify this all yourself. You can go to the same sources that I did, which were the U.S. Geological Survey, who has all this data on the Earth. You can go to the 3 or 4 independent surveys.
And it's accessible for anyone.
Yeah, right. It's pretty much the Smithsonian Institute publishes geodetic tables. That's where I got the ones that we were looking at here, and they're based upon dozens of ongoing measurements of the size and shape of the Earth, because they have to know that with precision in order to have satellites orbit and all of that. So it's there.
It sounds like a lot of work to research into all those numbers, and
it is, but it's a lot of fun if you're into that kind of thing. And it's fun when you connect the dots, when you see this for the first time. And that quote that I did from William R. Fix, he was the one, to my knowledge, who really put this, who first discovered this geodetic, how elegant this geodetic information was encoded into the pyramid. I hope he's still alive, and maybe he's still writing books, but I haven't seen anything lately. Who knows, maybe if he's out there, he'll watch this. And I'll just say that I was a big fan of your work, William, if you're still around.
This next architecture that we have on the screen, is this Stonehenge?
This is the ground plan of Stonehenge. Okay. Yes, and I don't know if we should get into the level of detail here, other than to say this: Stonehenge is also a monument to sacred geometry and the geometry of time. And some of the relationships that we found in the Great Pyramid are actually encoded here as well. I would have to get into some background information to really analyze what we're looking at here. I will just say that we talked earlier about the exercise in sacred geometry called squaring of the circle. And basically that's what's going on here. And maybe I can pull up one diagram that we can look at. Here we go. Okay, so you'll notice here's a geometric template laid over the ground plan of Stonehenge. There's a little variation. The variation may amount from a few inches up to 4 or 5 inches based upon multiple surveys of Stonehenge. They've all come out a little bit different. The point here is that if you use this particular template and you were to lay the template out with absolute precision on the ground, you were then to assemble stones according to that template. What you would have would be indistinguishable from what we see there in ruins, right? You see that the Star of David is in there, and you've got a hexagon in the middle that defines the diameter of the horseshoe, the bluestone horseshoe that's in the middle. And then you'll see that Star of David is enclosed by a circle, and that circle defines the diameter of the bluestone circle, which was a type of rhyolite. They used 2 different types of stone. They used a sarsen stone sandstone and a rhyolitic, which is an igneous rock, ultimately a lava rock. So, and here's the sarsen stone circle, and basically what happens is this: if you take the bluestone circle, you enclose it in a square, and then you precisely and carefully measure the perimeter of that square, it'll be the same measure as the circle that the sarsen stone is laid out on. And the difference between the bluestone circle and the sarsen stone circle, you see, is this same as the Earth radius and the lunar radius. So it's like the Earth and the Moon in a sense, you take those and put them tangent to each other, and they solve, on a three-dimensional astronomical scale, the squaring of the circle exercise, which to me is a really almost bizarre coincidence that it would do that, see? But when we get deeper into the, shall we say, the biological implications of this, I think one of the things is that the nature of the Earth-Moon relationship is such that without the moon, we wouldn't be here, right? We wouldn't exist. The moon, being the size, the mass that it is a prerequisite for there being enough stability, because the moon actually stabilizes the Earth and prevents it from rocking so chaotically that it would be impossible for higher life forms to develop. Also, because of the lunar tides, what it does is it allows for the creation of an intertidal zone. So the tides will cause the ocean to come up and to go back down, come up and go back down. So you've got a purely marine existence, a purely terrestrial existence, but then we have the intertidal zone, which is where the two great ecosystems come together, the great two ecospheres. And it's in that zone where you're able to get life from the ocean onto land. And if you look at this whole thing in a sort of a teleological sense, that it's not just that evolution is not an accident, but evolution is perhaps on some level I don't want to use the word directed, because I think of the analogy of a permaculture system. You know how permaculture works. Initially, you're creating a system that requires it's labor intensive on the front end. But as it develops and grows and evolves over years, typically 10 to 20 years, it becomes more and more self-regulating and self-perpetuating. So when a gardener or a landscape designer or a farmer creates a permaculture system, it's a lot of work on the front end. Once the system has been put in place, it's almost self-perpetuating, see? I kind of think of that permaculture model for the whole earth, you see. We won't go into who the farmer was, but it's interesting that one of the Egyptian terms for alchemy translates as celestial agriculture. But anyways, you've got that moon, it creates the tides, and now you've got an intertidal zone. So if you were a great architect who was trying to create a world, and you were trying to, nurture primitive marine life and eventually get it up onto the land where it can breathe air and stand up straight and have a vertical spine, etc., you need that intertidal zone. Otherwise, because that was the intertidal zone that allows those creatures to adapt to a habitat that has elements of marine and elements of terrestrial, instead of all at once. Because if there was no intertidal zone, some marine creature crawls out of the ocean and dies, and that's the end of the process. See, without the moon, no intertidal zone. Without the moon, Earth would rock chaotically, and it would be much too chaotic for so the moon, necessary. And to me, what's so beautiful and elegant about it is that the Earth-Moon relationship can be defined by this squaring of the circle exercise, the integration of, or the reconciliation of irreconcilables, the finite with the infinite, matter with spirit, rational with irrational, the circle and the square. So the resolution of that, and you cannot do it with exact precision, geometry, but you can approach it very, very close. And see, in utilizing geometry, whatever the ultimate life force is, it's utilizing geometry. But between the Platonic ideal and the real world, there's going to be variation. It's just like if I'm going to do a building project and I have a set of blueprints and it has dimensions on it, right? And those dimensions is on the plans, on the blueprints, can be perfectly precise. Now, I go out in the field with that, and depending upon my degree of craftsmanship, I build that structure. But no matter how good I am, there's going to be a little bit of deviation between the real world and the blueprint, right? Now, over the passage of time, the structure, which may have been built with a high degree of craftsmanship and conformed very, very close to the template, the blueprint template, it's going to move. It's going to, joints are going to open up some. It's going to weather. It's going to shift around. And, somebody coming 3,000, 4,000, 5,000 years later and measuring that, right, might be measuring something that's different than what was originally built. Then what you have to do in a sense is reverse engineer and try to figure out, well, what units of measurement were they using here? But the point is that between the ideal template and the real world manifestation of that pattern, there's going to be always discrepancies. It's the difference between the Platonic ideal and the real world that we inhabit, see? So when we look at these patterns, whether it's in Stonehenge, the Great Pyramid, the Earth-Moon relationship, or all throughout the solar system, which it is, in fact, all throughout the solar system, what we realize is that, okay, the perfect numbers might be 10,080, or 5,040, or 43,200, right? Mars is close to 43,200 Earth days. It's a little off. But you can go through these dimensions and these proportions with just a little bit of adjustment. And suddenly it's like all the perfect numbers fall in place, right? And then you realize, okay, so here's the template of the holy city as described in the book of Revelation, right? And you work through those numbers and you realize they're describing in verses or in scriptural form. They're describing, the book of Revelations has large parts of it are like architectural specifications. So when you go through and you read the description of the holy city descending out of heaven from God, and it describes a cube, and it describes a circle, and it gives dimensions of these, 12,000 furlongs, 144 cubits, and then you actually sit down, and we do this in my sacred geometry classes and workshops where we actually go through that, looking at it as if it was a set of architectural specifications. What you end up with is a pattern, and it's this pattern right here. The pattern that gives us Stonehenge, the pattern that gives us St. Mary's Chapel, the pattern at Glastonbury, the pattern that gives us... There we go. Okay.
Have you noticed such geometric ratios in crop circles?
To the limited extent that I have looked at crop circles, yes. And, I've been procrastinating because I've always said for years now, at some point I need to just get a whole collection of crop circles and begin to look at them, because I've seen lots of them where I go, yes, yes, okay, where I'm recognizing geometric systems. The one I happen to have in a program that I have with us tonight is this crooked sole, which was a crop circle that appeared, as it says, August 27, 2002. There's a very nice little book written about this, where they analyze the numbers that come out of here by looking at each of these squares, the number of squares in the total composition, the number of squares that shows that are in these prominences turn out to be significant numbers in that canon of sacred numbers that I've been referring to. This one is interesting because this is basically very suggestive of the DNA helix. And you see the helical, if we go to in the book, they did a really nice little color representation of the geometry of crooked sole. And you can see here, if you look at those, that's the two helical coils winding around each other, and here's the hydrogen bonds that link them together. It's right there. Now, where did this come from? I wouldn't venture to say. I haven't looked into that to where I feel like I have any great insight into it's either something mysterious we don't understand, or it is a group of really dedicated theater artists who have come up with ways of using technology and sneaking out into the fields at night and doing this.
But how long would it take to do?
Well, that's what I'm saying. They would have to be really good at what they do. To do something like this, you would have to probably be somewhere and rehearse it over and over and over, just like any choreographed piece, any theatrical piece where you would rehearse over and over and over again. I know that in a much scaled back way, when we do a job, we will, for example, go out with the crew and we will sort of do like a dry run, figuring out, okay, we're going to do this first, then we're going to do that, we're going to lay out this, then we're going to do that. Each person has a part that they're assigned, that they know what they're doing. So, if I was going to make that argument for this, I mean, that would be, I guess, the more reductionist or mundane argument is that it's humans doing it rather than some mysterious, intelligence or force or whatever. I have no final opinion on it. I'm open-minded. And again, it's one of those things that if there was a few more hours in the day, I would have investigated this more than I have. So I can't plead knowledge about this. But certainly I can see how maybe using technology, wearing night goggles and, if you've got a system of doing it, you would have to, again, it would have to be a team of people. They would have to be very skilled. They would have had to rehearse over and over again to where they could go out there and pull this off in a matter of hours. But I'm going to be honest, I don't know. If it's a mysterious intelligence behind this, call me. I want to know. I would like to know. Okay.
And what are your thoughts on the latest news about life compounds found on Mars?
Oh, I think that's totally awesome and fits what I've believed all along, is that life is extraterrestrial. Exogenesis, the idea that life has come out of the cosmos. I think, and that would be an interesting subject to talk about sometime, the idea of biogenesis, or the idea exogenesis, which is the delivery of the raw materials of life to Earth, and Earth provides the ideal test tube, the ideal environment then for the culturing and proliferation of life. You could take life, like for example Mars now, and nothing's going to happen to it. It's going to sit there in a frozen state. I honestly haven't really looked into what the latest findings are, although I'm sure I will very, very soon. But the idea, I think, is that, it's not going to do any good. It's like, I could throw seeds down on this floor and nothing happens. If I throw the seeds down into a nice prepared matrix of compost and soil and stuff, and I add the right water, something will happen. So I kind of look at Earth, it's to me, I don't want to be labeled any particular point of view. You've got the creationists, and the evolutionists. I figure it is evolution. But I have a hard time accepting the idea that the whole evolutionary process is just a random thing. Because, I mean, the intricacies of life, especially higher life, are so remarkable. How do you get that through just a succession of accidents? And then when you begin to look, see, one of the insights of this kind of study is when you look, we just talked about the Earth and the Moon. But you see, it's the whole pattern of the solar system. Because as it turns out, the likely vehicle for the delivery of organic precursors to the Earth is comets. But if the solar system was not arranged exactly as it is, that process couldn't happen. See, the geometry of the whole solar system basically is a reflection of this sacred geometry template. And in the advanced classes I do, we get actually into developing those geometries to see how the planets, especially the outer planets, the big ones, Jupiter, Saturn, Uranus, and Neptune, are linked into these geometries, and how those in turn link back to the geometries of the inner solar system. See, so again, we could go into great detail on this, but what the idea is that we live in a world that's perfect in a sense. And the parameters are so narrow, it wouldn't take much. If the Earth was a little bigger or a little smaller, it wouldn't work. If it was a little closer to the sun or a little farther away, it wouldn't work. If the moon wasn't there, it wouldn't work. If the big outer planets weren't there and weren't spaced precisely as they are, it wouldn't work. If the sun wasn't the size that it is, the whole thing wouldn't work. See? I don't know what the explanation for that is. See, I look at it and I go, when we see this, when we see creation, I think of the Native Americans who just called it the Great Mystery. It was the Great Mystery. And I don't think any theologian or any scientist has the answer to what all this is, where it came from, where it's going, how it came to be. To me, it's the Great Mystery.
And one final quick question I
Okay.
had for you. Is there a correlation between sacred geometry and free energy or 0 point?
That would be, I think that there probably is. I think that, that this is one of the really fruitful areas of exploration. And I've seen indications in the work of Tesla, in the work of Wilhelm Reich, in the work of Victor Schauberger, and a number of others that would suggest that, yeah, there is a geometric basis to energy generation, for sure. We certainly know that that's the case with the generation of nuclear power. It totally depends on the geometry of the uranium pile in order to generate the power through nuclear fission or nuclear fusion. So, yeah, I think we're just on the threshold of realizing that there are potentially, higher technologies that will eventually alleviate the need to use fossil fuels.
Thank you so much for sharing all these deep insights, Randall. And I deeply appreciate how gracious you have been with your time and effort for this presentation.
Well, it's really been a trying ordeal. No, it hasn't. It's been very much fun. I've enjoyed it. I've enjoyed meeting you, and I look forward to years of collaboration on this most interesting work that has to go forward.
I would love to collaborate with you.
Good. All right.
Thank you.
All right.
And your website is Sacred Geometry International.
Sacred Geometry International and Geocosmic Rex. Now, Geocosmic Rex deals a little bit more with like the Earth and the global change stuff than the sacred geometry stuff. But really, the two are very much complementary. And that's hinted at in the words geometry, measure of the Earth, geology, the study of the Earth, or the language of the Earth. So it's the two geos, and they do complement one another. And I hope anybody who's watched this gets a sense of that.
Thank you. And I want to thank viewers for watching this whole video. If you find all this information valuable, please remember to subscribe to my channel.